Hello, young and talented physicists. Welcome to class. In our last class, we talked about the concepts of heat and temperature. We were able to look at the differences between these two concepts. But today, we shall continue with measurements of heat energy, giving reference to specific heat capacity. I remain your host, Ajayi Sunday Aino. Have you ever wondered how energy is transmitted from a hot object to a cold object? The amount of heat energy in a body is measured by its mass if the temperature is constant. This is called heat or thermal energy. What are our learning outcomes? By the end of this lesson, you will be able to 1. Explain the term specific heat capacity. 2. State the SI unit of specific heat energy. Explain the term heat or thermal capacity. State the SI unit of heat capacity. Then solve simple problems using Q equals MC change in theta. So let's start by explaining what the concept specific heat capacity is all about. Specific heat capacity of a substance is the quantity of heat required to raise the temperature of a unit mass of that substance by 1 Kelvin. That shows that specific heat capacity is denoted by small letter C, and it is Q over the mass of the substance and the change in temperature. The SI unit of specific heat capacity is joules per kilogram per Kelvin. So if you look at this chart, you will discover that different materials have different specific heat. Now, having explained specific heat capacity, then let's consider the concept heat capacity. Heat capacity is also known as thermal capacity. Then it can be defined as the quantity of heat required to raise the temperature of a substance by 1 Kelvin or by 1 degree Celsius. Heat capacity is denoted by capital letter C, and the formula is C equals Q divided by change in theta. The SI unit from this formula of heat capacity is joules per Kelvin. Heat capacity is related to specific heat capacity by this formula. Heat capacity equals mass times specific heat capacity, as illustrated above. So let us now apply the formula in solving calculation-based questions. The first example we shall examine is this. Explain the meaning of the statement. The specific heat capacity of water is 4,200 joules per kilogram per Kelvin. So this is another way of asking you to define specific heat capacity. So the statement means that 4,200 joules of heat energy is needed to raise the temperature of 1 kilogram of water by 1 Kelvin. And let's look at the second example. The second example is, what is the quantity of heat that will be given out if a bar of brass of mass 350 grams is cooled from 95 degrees Celsius to 20 degrees Celsius? Given that the specific heat capacity of brass is 380 joules per kilogram per Kelvin. How do we go about the solution? You all recall that the quantity of heat is given as mass times specific heat capacity times change in temperature. So let us substitute the values The mass of the brass is 350 grams. We need to convert it to kilograms. So that is 0.35 multiplied by the constant, which is 380. Then the change in temperature is 75. So when you multiply all this, the quantity of heat that will be given out will be 9,975. Now let's look at this self-assessment exercise. So before we draw the curtain of this lesson, could you attempt these exercises? The first one is state the formula connecting thermal capacity and heat capacity, while the second one is state the SI units of specific heat capacity. In conclusion, having considered how heat energy is needed to raise or change the temperature of a unit mass of 1 kilogram of a substance by 1 Kelvin, you need to be aware that heat content of a body depends on the mass of the substance, the rise in temperature of that substance, and the nature of that substance. Thank you very much. I want to believe you must have gained one or two things from our class today. I want to urge you to keep a date with me in our next class. Thank you and God bless. I remain my humble self, Ajayi Sunday. I know.